Hello, welcome to my YouTube channel, MQA Tutorial 5. We'll take a look at Icf file and var file today. The first section of the Icf file defines the node. It is the node section. So the definition is also very simple. And this is a commonly seen one like DGSB, and the three arguments for the DGSB. So what's that meaning? We can see it starts with a number. So here's the definition. The node name and then the index of the node. The index just a number. It starts from 1. It can be 1, 2, 3, 4. And if you have more, you can add 5, 6, 7, like that. And the second argument is ground. It is a flag indicating whether this node is grounded or not. It has only two values. 0 means it is ground node. Null means it's not a ground node. And the third argument, index of port in AC network. The node and the port here can not only be used for the DC simulation, it can be used for AC, RF, those simulations as well. So this is the index of port in AC network is used for the AC. It's an index of port in two-port network for AC simulation. 1 means port 1, 2 means port 2. 0 means this node is not used for AC signal. In most of the example Icf files in the EDC folder, we have given 4 nodes DGSB, which is commonly used for the MOSFET device. But in some cases, user may need to use 5 terminal devices, 6 terminal devices, or even 7 terminal. In that case, you can just add more nodes in your Icf file. For example, we're adding a fixed terminal P. The index is 5, it's not grounded, and it's not used for AC signal. So it's 5 now there. Okay, the next section is about connection. Like the VG, it's connected between G and 0. It's a voltage. In and out is for DC. And the VGS is connected between G and S. It's a voltage. And the in and out is also DC. And frequency F, Y, those are used for the RF part. The third section of the Icf file is variable. You can also call it a target. If you remember in the rule file part, in each rule item, there's a target definition of what you want to calculate. For example, if y equals VTH, you're using that target directly. That means that VTH target has been defined in the Icf file in the variable section. Target or variables defined here, you'll be able to use them directly in the target part of the rule. The fourth section of the Icf file is instance, just the instance name. Just make sure they match with what defined in the model file. And the last section is OP. OP is a special target. In this file is a HSpice for my Icf file. In HSpice, you can use the LX method to get output. If you want to use them as a target inside MQA, you can also use the OP method. After the Icf file, let's take a look at the var file. There are only two main sections in the var file. The first section is the common variables, defines the default constant library with the variable name equals a value. The second section, named based on device polarity, as the example shows on the right. This is the only part of it. It actually contains both NMOS and PMOS. The variable name on the left side of the equal is the display name on the GUI. The next variable on the right side of the equal is the variable defined in common section. All these values and variables are defined for providing default values. So if you have a unified bias condition and the device geometry set, it can be defined in variable files. So the default values are not necessarily modified every time. Okay, that's for the Icf file and the var file. So far, we have learned all the rule files, Icf file, var file. If you have learned how to customize those three files, you have already become an expert for MQA. Okay, thank you.